haloalkanes and haloarenes. Haloalkanes. Haloalkanes means organic compound containing one or more halogen atom, fluorine, chlorine, bromine, iodine, in place of hydrogen atom of alkane. Means in alkyl group one hydrogen is replaced by halogen. And general formula is Rx, where X is equals to fluorine, chlorine, bromine, iodine. And nomenclature means named as halo plus alkane, CH3Cl, chloromethane. Physical properties: higher members are insoluble in water, soluble in organic solvents. Means those are possessed high members of alkyl haloalkanes. These are insoluble in water, but they are soluble in organic solvents. Uses: solvents, refrigerators, and insecticides, anesthesia. And next one is haloarenes. Halogen atom is directly attached to the aromatic ring, means we call it as haloarenes or aryl halides. General formula: aromatic and halide. Example: fluorobenzene, chlorobenzene, bromobenzene. Means in this one hydrogen is replaced by fluorine, chlorine, or bromine. And nomenclature of haloalkanes: CH3Cl, chloromethane, chloroethane, 2-chloropropane. Chlorobenzene is the example of aromatic aromatic. Uses of haloarenes: chlorobenzene, solvent intermediate, iodoform, antiseptic, DDT, insecticide, some used in medicines and dyes. Classification of haloalkanes and haloarenes. First one is by number of halogen. Monohalogen means one halogen atom is present, means monohalogen. Dihalogen means polyhalogen, means two or more halogen atoms are present, means uh, dihalogen. And next one is by nature of halogen: fluorocompounds, chlorocompounds, bromocompounds, iodo-compounds. By nature of carbon halogen bond: alkyl halides, aryl halides. Alkyl halides means carbon and halogen in alkyl group, and aryl halides means halogen is directly attached to the aryl ring. Preparation of haloalkanes. First one is from alkanes by free radical halogenation. When methane is treated with the chlorine in the presence of sunlight, it gives chloroform. It gives H3Cl and HCl. And from alkenes, by addition of HX or X2. When alkenes are treated with the HCl, it gives CH3, CH2Cl, means alkyl halide. From alcohols, by reaction with HX or PCl5. When alcohols are treated with the hydrogen chloride, it gives corresponding halides, alkyl halides, and water. Remove water. Next one is reactivity of alkyl halide. Alkyl halides are more reactive than corresponding alkanes due to polar covalent. They will undergo nucleophilic substitution reactions. And bond energy: carbon iodine 57.4, carbon and bromine, carbon and chlorine, carbon and fluorine are given. In this iodine, carbon and iodine bond energy is very low, and carbon and fluorine bond energy is very high. So carbon iodine is more reactive than all other halogens. It will easily break the bond in between carbon and iodine, so it is more reactive than other halogens or than other haloalkanes. Preparation of alkyl halides. First one is by direct halogenation of alkanes. In that chlorination, in presence of diffused sunlight or UV light or at high temperature, it gives haloalkane. Already we seen that is nothing but when ethanes or alkanes are treated with the chlorine in the presence of sunlight, it gives haloalkane. Next one is bromination. by heating in presence of AlBr3. When alkanes are treated with the bromine in the presence of AlBr3, it gives RBr and HBr. It is a chain reaction via free radical. Stability of free radical. Tertiary is greater than secondary is greater than primary. During reaction, polyhalogen derivatives are also formed. Reactivity of hydrogen atom. Tertiary is greater than secondary is greater than primary. Iodination. Direct iodination is reversible. HI reduces alkyl iodide. So RH plus I2 means it will form Ri, and again it is a reversible reaction. It will again form alkane and I2 only. Then in presence of oxidizing agents like H2O, HiO3, HNO3. Then alkanes are combined with iodine and form alkyl iodide. And reaction can be stopped at monoid stage. Reactivity of halogen with alkanes. Fluorine is greater than chlorine is greater than bromine is greater than iodine. By addition of hydrogen halide to alkenes. Order of reactivity of hydrogen halides means HI is greater than HBr is greater than HCl. Symmetric alkanes. Hydrogen halides are addition with alkanes from single product, hence it is called as simple addition. When symmetric alkenes are treated with hydrogen halides, it gives alkyl halide. And unsymmetrical alkenes. Hydrogen halide on addition with unsymmetrical alkenes form two different products, and the formation of major product is decided on the basis of Markovnikov rule. Negative part of the hydrogen halide means during the addition of any unsymmetric reagent like hydrogen halide in any unsymmetric alkenes, negative part of the hydrogen halide, that is X halogen, is linked to the carbon atom of double bond having less number of hydrogen atoms and form the major product. Example, when alkenes are treated with the hydrogen halide, the negative part of the hydrogen halide attack to the less number of the hydrogen which possesses double bonded carbon. It is the major product, and it is an electrophilic addition reaction and proceeds through the formation of stable carbonium ion as intermediate. And next one is peroxide effect or anti-Markovnikov rule. Karashmayev effect. HBr on reacting with unsymmetrical alkenes in the presence of organic peroxides undergo addition reaction in which HBr is linked to the carbon atom of double bond having more number of hydrogen atoms and form the major product. Example, when alkenes are treated with HBr in the presence of peroxide, it gives Br attack to the double carbon which possesses more number of hydrogen, and positive part of the hydrogen ion is attached to the double bond carbon which possesses less number of hydrogen. It is not applicable for the HCl and HI. This mechanism is free radical mechanism. And important points we should aware of this. Reactivity of alkyl halide Ri RBr. Ri is greater than RBr is greater than RCl is greater than RF. Carbon halide bond strength is equals to RF is greater than RCl is greater than RBr is greater than Ri. Means carbon and halogen bond strength is directly proportional to the electronegativity. As nuclear charge increases, bond strength will be increases. And stability of free radicals, tertiary is greater than secondary is greater than primary. Reactivity of hydrogen atom in alkanes also, tertiary is greater than secondary is greater than primary. Alkyl halide undergo nucleophilic substitution reaction. Preparation of alkyl halides using hydrogen halides. Alkyl chlorides. Alcohols on heating with HCl in the presence of anhydrous zinc chloride produce alkyl chlorides. When alcohols are treated with the HCl in the presence of anhydrous zinc chloride, it gives RCl and remove water. Mechanism: when alcohols are treated with the HX, H plus is attached to the oxygen and it gets a positive charge and it removes water, and so it gets positive charge carbocation. The negative part of the HX X is attached to the carbon and form a product as RCH2X. And next, intermediate carbocation is formed, so rearrangement H plus shift or CH3 shift can take place. Mixture of concentrated HCl and anhydrous zinc chloride is called as Lucas reagent. Decreasing order of reactivity of alcohols is tertiary is greater than secondary is greater than primary. Reactivity of alcohol is directly proportional to the stability of intermediate carbocation. Reactivity order of HX is HI is greater than HBr is greater than HCl. Next one is alkyl bromides. Alcohols on treating with uh, alcohols on treating with NaBr and concentrated H2SO4 produces alkyl bromides. Example: ROH plus HBr in the presence of NaBr and H2SO4 it gives RBr and remove water. In case of secondary and tertiary alcohols, diluted H2SO4 is to be used because concentrated H2SO4 dehydrate them. And next one is alkyl iodides. Alcohols on heating with HI form alkyl iodides. When alcohols are treated with the HI, it gives Ri and remove water. During this reaction, yield is low. HI reduces Ri in alkane. To increase yield, alcohols are treated with the sodium iodide or potassium iodide with 95% of phosphoric acid. ROH treated with Ki in the presence of H3PO4, it gives alkyl iodide. Next one is using PX3, uh, alkyl chlorides. When alcohols are treated with the PCl3, it gives RCl and H3PO3. Alkyl bromides. When alcohols are treated with the bromine PBr3 in the presence of red phosphorus, and by heating it gives 3RBr plus H3PO3. PBr3 is unstable reagent and prepared in situ from red phosphorus and bromine. Next one is alkyl iodide. Alcohols are treated with the iodine in the presence of red phosphorus plus iodine. It gives alkyl iodide and H3PO3. Pi3 is unstable reagent and prepared in situ from red phosphorus and iodine. Next one is using PCl5. ROH and plus PCl5 it gives RCl plus POCl3 and HCl. PBr5 and PI5 does not exist due to large size of bromine and iodine. It is important why PBr5 and PI5 does not exist means due to the large size of bromine and iodine. And next one is using thionyl chloride, Darjan's procedure. It is also called Darjan's procedure. When alcohols are treated with the SOCl2 thionyl chloride in the presence of pyridine, it gives RCl and SO2 and HCl. SOCl2 is the best reagent used to prepare RCl because SO2 and HCl are gases and are easily removed from reaction mixture. All these are nucleophilic substitute reactions. Reactivity of alcohols towards this reaction is tertiary is greater than secondary is greater than primary. We should note that in every reaction, reactivity of alcohol is tertiary is greater than secondary is greater than primary. And PBr5 does not involve because large size of bromine and iodine. Thionyl chloride is the best reagent because SO2 and HCl gases easily removed from reaction mixture. It is nucleophilic substitute reaction. And by halogen exchange, first one, Finkelstein reaction. When alkyl chloride or and bromides on reacting with sodium iodide in the presence of acetone form alkyl iodides. NaCl and Nab are easily precipitate in acetone. Example Rb or RCl plus NaI in the presence of diacetone, it is Ri and NaBr or NaCl. Acetone is used to precipitate the NaCl or NaBr. Usually Finkelstein reaction is for producing or forming alkyl iodide. Next one is Schwartz reaction. Alkyl fluorides are prepared by the heating alkyl chlorides and bromides with metallic fluorides like AgF, COF2, SbF3 and Hg2F2. RCl or RBr plus AgF gives rise to RF plus NaCl NaBr. Next one is nucleophilic substitution reaction. Involves replacement of halogen atom by nucleophile. Occurs in both haloalkanes and haloarenes. Order is tertiary is greater than secondary is greater than primary. For alkyl halides. Example alkyl halide CH3CH2Cl is treated with ammonia. It gives CH3CH2NH2 plus HCl. Mechanism NS1 if tertiary is present, primary is present means NSN2. An electrophilic substitution reaction occurs in aromatic compounds, haloarenes. Halogen acts as deactivating but orthone pyradirecting group involving formation of sigma complex. Example bromobenzene. Formation of alkene. Dehydrohalogenation. With alcoholic KOH heat follows Judge's rule. Major products are substituted. Secondary is greater than primary. Example formation of propane. Next one is formation of alkyne. Double dehydrohalogenation. With excess of alcohol and alcoholic KOH and heat. Primary secondary alkyl halides give alkynes. Example formation of propane by using bromopropane and excess of alcoholic KOH. And next one is reaction with sodium alkoxide. Williamson synthesis from ethers. Primary alkyl halide should be present because less steric hindrance. Example CH3CH2Br is treated with the 2Na and 2Na means 2 moles of alkyl halide treated with the 2 moles of sodium. It gives alkane. It gives ethyl methyl ether. And next one is reaction with Grignard reagent. When RMGX is called as a Grignard reagent, reacts with carbonyl compounds. It gives alcohol. Next reaction with AgNO2 gives nitroalkane with AgNO2 in alcohol. When alkanes are treated with AgNO2, it gives RNO2 plus AgX. Next one is reaction with sodium or KCN gives nitrile with sodium cyanide in alcohol. When alkyl halides are treated with the sodium cyanide, it gives nitrile. And important point that tertiary alkyl halides are more reactive SN1, primary are least SN2, and haloarenes do not undergo SN1 or SN2 easily due to resonance. Electrophilic substitution occurs in haloarenes. Lucas reagent means concentrated H2SL and anhydrous zinc chloride. Tertiary is greater than secondary is greater than primary.